Hello everyone again. I'll be presenting our second paper titled Enhancing Large Language Models Based Arabic Negotiation by Fine-Tuning on Short Dialogue Shortcomings. This paper was done in collaboration with the American University of Beirut and Qatar University, done with the following professors, Hazem Hajj, Shady Elbassuoni, Wassim Hajj, and Khaled Shaban. Starting with negotiations are central to various human interactions, starting from everyday market dealings to diplomatic talks, contract negotiations, and much more. With the rise of chatbots,
a full screen or diaporama?
Are you not able to see my full screen?
Because now we just see your control screen, but we don't see the full screen.
Okay, let me try sharing again. Does it work right now? Can you see my full screen?
Yeah, that's good.
Okay, great. As I said, negotiations are central to various human interactions, from everyday dealings to diplomatic talks. And with the rise of AI chatbots, we see a need to basically add intelligent agents and AI agents that use natural language generation and natural language understanding. This means that negotiation now has to involve both linguistic skills and strategic reasonings. In this paper, we basically tried to understand what the challenges that LLMs face. Specifically here, we have a case study on GPT-3.5 Turbo in Arabic negotiation based on different tests that we conducted. Turns out that in Arabic negotiation, AI chatbots fall into three main problems: chain of thought reasoning, numerical precision, so inaccuracies in mathematical reasoning and calculations, pronoun inconsistencies, and pronoun referencing, specifically in Arabic language. Therefore, the aim of our paper is to enhance LLM's capabilities in Arabic by, first of all, identifying the limitations of LLMs in Arabic negotiation, fine-tuning GPT-3.5 for improved reasoning and linguistic accuracy, and developing a comprehensive Arabic negotiation dataset to fine-tune the model, and introducing an evaluation framework for measuring the model's improvements. First of all, we started by conducting testing on very popular LLMs, GPT-3.5 Turbo, Gemini, LLaMA 2, and Bard. Then moving on, we were able to identify issues in the Arabic negotiation scenarios, which were, as stated before, mathematical reasoning errors, common sense gaps, which is the chain of thought reasoning, and pronoun inconsistencies. And basically, this allowed us to basically select GPT-3.5 to enhance using fine-tuning to improve its reasoning, negotiation abilities, and linguistic consistency. The experimental evaluation of GPT-3.5 in Arabic negotiation scenarios was as follows. We basically prompted GPT-3.5 to simulate negotiation dialogues between, again, Amani and Samir, if you remember the previous paper, the buyer and seller, to maximize values for each agent. So we have one book, 3 hats, and 1 ball, each item valued differently for each player, and they'd have to split them evenly between them in a way that maximizes the value for each agent. We conducted this for 10 runs and found issues in logical operations, common sense reasoning, and pronoun consistency. In order to fine-tune GPT-3.5, we had to curate a comprehensive data set. We did that by basically prompting GPT-4 to create a generalized data in the following different categories: regular negotiation dialogues, which had negotiation strategies, tactics, and both the buyer, the seller, in different currencies and different locations, different items. We have arithmetic-based negotiation that has calculations, chain of thought dialogues that had, this chain of thought reasoning and following along, pronoun consistency, and one that basically combined a mixture of all the different sets. So we had a total of 1,400 negotiation dialogues, took 1,000 balanced ones for training, and 400 randomly sampled for balanced evaluation. So we fine-tuned GPT 3.5 on the GPT-4 synthesized dataset after converting it into a chat-based negotiation format, trained over 3 epochs with the following hyperparameters: learning rate multiplier and dynamic batch size, got an average accuracy of around 90% with a training loss of 0.39. Okay, in order to evaluate our fine-tuned model, we had 3 different metrics. So negotiation performance, where we looked at the success rate. So how frequently are we reaching successful agreements in simulated negotiations? Price agreement. So in comparison to the generated price versus the one in the testing set, how effective is the negotiation for the buyer's strategies and for the seller's strategies, or both? Discrepancy in the price negotiation versus the one found in the testing, and response length or negotiation length. We have the pronoun consistency. So how well is the model able to follow in the pronouns in the dialogue, and arithmetic accuracy. For the more complex metrics, we use GPT-4 to assess them and to figure them out. So starting with the response length and efficiency, we can see that in the average expected word count versus the generated word count, we have longer generated dialogues for the fine-tuned model, indicating more advanced and complex negotiation strategies, and the diversity in the interquartile range suggests that we have adaptive strategies similar to human negotiations. As for when it comes to the negotiation success rate and the level of agreement, we can see an improvement in the negotiation success rate pre and post fine-tuning, where we actually saw statistical significance here. As for the level of agreement, it remained consistent with the expected outcome. So we maintained the agreement quality. Okay, as for negotiation prices, here we can see we have the prices compared to the testing set, if it was higher, lower, or the same. In the case of the higher, basically here we had higher prices were generated when we had seller tactics, and lower prices were generated when we had buyer tactics. And basically, we had a combination of both when we had both tactics. So this means that the model showed an understanding to negotiation rules and adjusted prices according to which tactic was used. Okay. Pronoun consistency, again, we used GPT-4 to correctly identify the gender pronouns and see what's going on. So we had consistent accuracy across all scenarios, whether it was pronoun dialogues and chain of thought, or in mathematical dialogues, or purely in just pronoun dialogues. So it basically grasped the Arabic pronoun rules. Okay, arithmetic capabilities, again, we had a near perfect accuracy in scenarios that involved the need of mathematical equations and the use of mathematical capabilities to reach a certain end. So this was basically, reflected effective fine-tuning for numerical reasoning. Okay, if we want to compare the original and the fine-tuned model in terms of the qualitative output. So the base model sometimes deviated from prompts. It went to unrelated topics and sometimes inaccurately changed the item prices, while the fine-tuned model showed enhanced precision in maintaining prompt adherence. and stayed more on topic and did not shift erratically and sporadically from topic to topic. And of course, the fine-tuned model was more coherent. As for currency handling, the base model switched from currency, which sometimes highlights the lack of contextual awareness, whereas the fine-tuned model stuck to the currency specified. Here we can see a comparative analysis of the output where we would just have a shift. And let's say we were starting with USD or euros, and suddenly we'd go to a much different currency and the base model, let alone shift on the topic of negotiation as well. So as a conclusion, basically, this paper presents a contribution to the Arabic NLP domain, where we try to enhance AI negotiation and presented and demonstrated effectiveness of fine-tuning to address language-specific challenges. Key achievements were fine-tuning success, where we improved it on different aspects involving arithmetic operations, pronoun consistency, and sticking to more coherent and complex dialogues. As for future directions, we're trying to prepare the dataset for public release and maybe try to adapt this for other languages, or even include multi-modality negotiations as well. So again, this paper was done thanks to a grant from Qatar National Research Fund. And thank you for listening. I'm open if anyone has any questions.